first thing we're going to do is we need to graph polar points. All right. A polar coordinate system is just a different way of graphing points in the plane. The polar axis is the positive x-axis. So this is your polar axis right here. And the way that you graph points is you go counterclockwise from the polar axis, and then you also have, that's the second, so that's your direction, that's the second value of the point. The first value of the point is your radius, or how far out of the circle you go. So the point 2, 5 pi over 6 means you're going to go around to 5 pi over 6 and out 2 little circles. All right, 3, negative pi over 3. How do you think you deal with the negative pi over 3? Good, you go clockwise instead of counterclockwise. So negative pi over 3 is actually going to put you at 5 pi over 3, and we go to the third circle. All right, now when the radius is negative, that's the one that's kind of weird. We're going to go to pi over 4, which is not labeled here, but this is pi over 4. But instead of going 3 in the direction of pi over 4, we're going to go 3 in the exact opposite direction. So it's going to put us right here for point C. So if your radius is negative, you just go, instead of going out to that same angle measure, you just go 180 degrees in the opposite direction. Okay, each rectangular coordinate is unique. What I mean by rectangular coordinate is just an x, y. However, it's not the case with polar coordinates. There are an infinite number of polar coordinates that represent each point. The pole is represented by 0, theta, where theta is any angle. So your pole could be at 0, pi over 2, 0, 7 pi over 6, 0, whatever, at any angle, but the radius is 0. So the next thing we're going to do is we're going to name 3 other coordinates that represent the point negative 2, 7 pi over 6. All right, so first off, negative 2, 7 pi over 6 would be go to 7 pi over 6, but then I've got to go the opposite direction, so it would be right here. And I want to name 3 points that all fall where theta is between negative 2 pi and positive 2 pi. So what's another way that I could name that point? Yeah, 2, pi over 6. Good. Perfect. 2, negative 11 pi over 6. So starting and going in the negative direction. Okay, one more. Yep, we are going to use a negative 2 and negative 5 pi over 6. Good. Because negative 5 pi over 6 will be coterminal with the 7 pi over 6, and then the negative will bump us over to the other side. So if you're doing that, I think it's helpful to graph the point that's given to you and then kind of work from there. Okay, convert the rectangular point, negative 4, 3, to a polar coordinate. I'm a very visual person, so I kind of like to see what I'm doing. Negative 4, 3. Is going to be about right here. And because thetas are involved, I'm kind of thinking, and angle measures and radians, I'm kind of thinking trig. So what I'm going to do is I'm actually going to draw a rectangle out of this triangle. Excuse me. And the easiest thing to do is to find the radius. So the radius, or the first point in my polar coordinate, is what part of this picture? The hypotenuse. Good. And we went 4 to the left, and then up 3, so the hypotenuse has a length of 5. Okay, now my theta is going to be the angle from the positive x-axis all the way around to that hypotenuse. Yeah, Okay, we're going to find the reference angle, and then once we find the reference angle, we can get that actual angle. How can I've labeled it x. How can I figure out what x is? Okay, I could use sine, cosine, tangent. I have the habit of using tangent just because the 3 and the 4 were already given to me. So I'm going to say the tangent of x equals 3/4. I'm actually not going to put the negative in there. Why not? Right, it would make it down. I would get an angle down in the 4th quadrant, and by just making it positive, I'm going to get the reference. I'm going to force my calculator to give me the reference angle. All right, make sure that your calculator is in radian mode, and you would type in tan inverse of 3/4. Okay, you should get 0.644. Right, that's not my theta, because my theta needs to be the angle from the positive x-axis to the hypotenuse. So what's the relationship between x and theta? Yeah. Pi minus the 0.644, which is 2.498. So the point is 5, 2.498. R always comes first. Okay, convert the polar coordinate to a rectangular coordinate. What quadrant is 5 pi over 6 in? 2. Okay. And then the length is 3. So now I need to find x and y. If theta is 5 pi over 6, what's the reference angle? Pi over 6 or 30 degrees, if that helps you. We can actually do this one without a calculator. So I have a 30, 60, 90 triangle here. So if the hypotenuse has a length of 3, what's the length of the short side? 1.5, 3 halves. I'm just using a special right triangle, a 30, 60, 90 special right triangle. But I could also use trig. So it's 30, so 1, 2, and root 3. So x is going to equal negative 3 halves root 3, or negative 1.5 root 3. And you just have to kind of pay attention for the x's. But we could also have set up like the cosine of 30 equals x over 3, and the sine of 30 equals y over 3, and solve those equations. If you use the 30 degrees, the reference angle, then you have to remember that your x value is negative. You could actually have used the 5 pi over 6 instead of the 30 and gotten, because the sine of a second quadrant angle is still going to be positive, which our y value should be positive, but the cosine of a second quadrant angle is negative, so it would have given you the negative right there. There we go. All right, the next page kind of summarizes what we just did. There are formulas for doing that. Coordinate conversion. And you can memorize those if you want, but I think it's kind of easier to draw a picture and just work your way through it. But anyway, you can do that if you want. All right, the next thing is we're going to convert a rectangular equation to polar form. And that, actually, you do kind of need these conversions right here. X squared plus y squared equals 25. In rectangular form, what is that the graph of? It's a circle with a radius of 5. Good. So I want to change this to polar form. And that means get rid of x's and y's and get r's and or thetas in there. So what can I replace x squared plus y squared with? R squared. Yeah, x squared plus y squared is r squared. So r squared equals 25. And usually you try and solve for either r or theta. if you can. So you could take the square root of both sides, and r would equal 5, or r could equal negative 5. And just like you can have multiple points, multiple names for each point, you could have multiple names for each equation. If you think about a radius of 5, doesn't matter what your theta is, you're always going to have a radius of 5. If your radius is negative 5, it's going to be the exact same thing, because if your theta is, say, pi over 4, then the negative 5 is going to bump you to the opposite side first. So either way, it's the same. I would probably just say r equals 5. Okay, x equals 12. What does that look like in just rectangular form? It's a vertical line. Good. Okay, what can we replace x with that has r's and thetas? Yep, r cosine theta equals 12. And we usually solve for r, so if you divide both sides by cosine, either 12 over cosine theta, or what's another way that could show up? Yep, 12 secant theta. Okay, we're going to go the opposite direction now. Convert the polar to rectangular. Okay, we had up the top that x equaled r cosine theta, and y equals r sine theta. And the tan of theta equals y over x, and r squared equals x squared plus y squared. Okay, so I need to get rid of thetas and r's, and I want to get to x's and y's. What do you think? Good. If you divide both sides by cosecant, you get r over cosecant, which is the same thing as r sine theta, equals 2. And then part B, theta equals 7 pi over 4. I want you to visualize what the graph, what the polar graph of theta equals 7 pi over 4 would look like. Is there anything? There's nothing about r in this equation, so it just means that your theta is going to be 7 pi over 4. So it would just be a straight line wherever theta is 7 pi over 4. Is it going to extend in the opposite direction? Good. It would extend in the negative direction, because if r, you don't know anything about r. If r is positive, then the line's going to be going down. But if r is negative, it's going to be the other side of it. All right, so if theta equals 7 pi over 4, I'm trying to get back to y's and x's. So I'm just going to use the fact that tan of theta equals y over x. So the tan of 7 pi over 4 equals y over x. And I have the ability to find the tangent of 7 pi over 4. It would be negative 1. If you cross multiply, you get y equals negative x, which kind of makes sense. All right, last thing we're talking about are points of intersection of polar graphs.